this is problem 522 from your book. So with this one, the problem statement reads, if the intensity of the distributed load acting on the beam is W equals 3 kilonewtons per meter, determine the reactions at roller A and roller B. So the load is distributed over that whole 4-meter piece that you can see in the drawing I did there. So basically, with this one, what we want to do first is draw a free body diagram. So I'm going to pause it. So I just drew a free body diagram. Basically with this, had to replace the forces at each of the reaction points. So at A there was a roller. I guess I didn't actually draw the problem very good. Let's see. There's a roller at A, and then at B there's a pin. And if you look at the chart, or table 5.1 on page 210, it tells you that for a roller, basically the resulting force is just perpendicular to that surface. So at A, I just drew the force in that direction, and we know something about this because we know the direction of the angle. So we can figure out the direction of that A force, but we don't know what the magnitude is. For the W force, it's distributed load across that whole 4-meter section. So it's 3 kilonewtons per meter times 4 meters, because it's over that whole section, and it's basically equal to the area under this curve here. If it were a triangle, we'd take a half of it, because that's how you figure out the area of the curve. But since this is just a straight line, it's just the area under the curve. So we get 12 kilonewtons. I replaced it by a resultant force just in the center. Since we're not cutting off part of it, we're interested at the very end B, we can just take that resultant force to do that. So basically, after we draw a free body diagram, so we're going to make X to the right, Y up. I think I've got everything labeled. We basically have 3 sets of equations and 3 unknowns. So our 3 unknowns, we have bx, by, and a are the 3 things that we need to know. So we have 3 equations. We can sum the forces in the x direction are equal to 0, sum the forces in the y direction are equal to 0, and sum them a point are equal to 0. So our 3 equations. So we've got these 3 equations, we have our 3 unknowns, so we're ready to go. If we think about, we can just start with any of them, and sometimes we'll end up with 2 unknowns. So with the B, we have an x and a y component. With the A, we have an x and a y component. So if we do either of these 2, we're going to have 2 unknowns in those equations. For the sum of the moment, if we're smart about it, we can only have 1 unknown. So first we want to pick our point. So let's pick a point that makes the most sense. So which point do we know the least about? I would say it's point B, because we don't know anything about bx or by. At least with A, we do know the direction. So let's sum the moment about that point B equal to 0. So summing the moment about point B, so we have the weight, and let's do the coming out of the board as positive. So if we go from B to where the weight's hitting, so halfway on that AB, or on that bar, our fingers go down, the moment is positive, it's coming out of the board. So positive, that 12 kilonewtons times that perpendicular distance is 2 meters. And then we have the moment due to the force over with the, due to the A. And remember, A now has, let me do a different color. See, A has 2 components. We have the X component of A, and we have the Y component of A. And then we know the angle there. So if we first go with the X component of A, then we just need to know that perpendicular distance up to there. So, and let's figure out if it's positive or negative. We go B all the way up to A, and then we do our fingers in that direction of that AX, so to the right. It's going into the board, so the moment's going to be negative. And then we want to do of that AX. So AX is going to equal A, which we don't know that yet, times the sine of 30 degrees. It's the opposite of where that 30-degree angle is. And then we want to multiply that times that distance, the perpendicular distance down to B. So it's basically this distance here is what we're interested in. So that's that perpendicular distance. We know that this is 3 meters here. We know it's a 30-degree angle. So we can do 3 meters times the sine of 30. and that'll give us that perpendicular distance. And then we also, so we have the AY also that's going to produce a moment. And that AY, let's do our right-hand rule, so go from B up to A, do our fingers in the AY direction, so that's also going into the board. So that's going to be negative, and AY is going to equal A times the cosine of 30 degrees, so that's this component right here. And then we want to multiply that times this perpendicular distance from that point B to there. So it's going to be 4 meters plus 3 meters times the cosine of 30 degrees. And that's going to equal 0. So this is kind of good. So we have our A's are unknown. There's nothing else. So we should be able to figure it out. So I'm just going to pause it and go to my calculator, and I'll be back in a second. So I'm just going to go ahead and write down stuff. So it's, let's see, it's 24 is that first one, minus 0.75 times A, minus, and then we have A cosine 30 times 4, so 3.464A minus, so that was just this times that, and then A cosine 30 times 3 cosine 30 minus 2.25A, and that equals 0. Alright, and then I just paused it and just checked my math to make sure it was right. So now we do have the negative 2.25 minus 0.75, so that gives us negative 3A. I'm going to move it over to the other side, so 3A equals, and then, oh wait, we had this too, sorry. Let's see, undo. So we have, let's see, this and this is negative 3A, negative 6.464, so 6.464A equals 24. Yep, just check that, that's right, because I sorted it in my head. And then I'm going to figure out what A is. So we get A equal to 3.71. And that would be kilonewtons. Alright, so now we've got A. So we still have 2 unknowns. Fortunately, we have 2 more equations. So I'm just going to go on to the next page. Alright, now we're going to sum the forces in the x direction equal to 0. And let's see, that A is 3.71 kilonewtons. So to sum the forces of the components of the x, we have the x component of the A force, so that's that 3.71 kilonewtons times sorry, I just went back, times the sine of 30 degrees. That's the x component of the A. W is all in y, so we don't have to worry about it. By is in the y, and then bx, so minus bx equals 0. So bx is going to equal 3.71 kilonewtons times sine of 30. That's going to give us bx equals 1.86 kilonewtons. And now we can do our last one, which is the sum of the forces in the y direction equals 0. And for that, we're going to have that the y component of the A, so that's 3.71 kilonewtons times the cosine of 30 degrees, minus that W, which is 12 kilonewtons, and then plus By equals 0. So By is going to equal, I don't know where that line came from, so it's 12 minus the 3.71 times the cosine of 30. So we get 8.79 kilonewtons. Cool. So now I'm just going to go back to my find statement. So that it said to find the reactions at roller A and pin B. So we found A, BX, and BY. So we're all good to go.